Okay, so today we're going to talk about constructing exponential functions. It's day 148. So I've taught you before linear functions, linear, okay? Turn to your neighbors and remind them, what is the equation for linear? Y equals what? Turn to your neighbors and tell them. What was that? Remind them. What is linear? Okay, what's a linear function? What's a linear function? What is the equation? Y equals what? Nope. No, what's a linear function? Okay, so we're going to go thinking about linear, okay? So linear equations. Let me pull up my presentation here from earlier. Okay, so linear is y equals mx plus b. What does the m and the b stand for, everyone? What do m and b stand for? Slope and y-intercept. Good. Remember that? So it affects where it is on the line. So can we all graph that with slope and y-intercept? Good. Okay, so I want to show you that now there's this thing called exponential. So exponential graphs or functions have this, and I need to memorize this one now. Y equals a times b to the x. Okay? So turn to your neighbors. Look, remember from yesterday how we had y equals a1 times b to the n minus 1. Remember that yesterday? Talk to neighbors and tell them how this is similar or different from yesterday. Okay? Ready, set, and go. Let's hear some talking. How is this similar and different from yesterday? A and B are still there. What did A represent yesterday?
First term.
The first term. And what did B represent, everyone?
Ratio.
No, that's second term. The ratio. Good. Ratio. Remember how we multiply it by the same amount? 2 times 2 is?
4.
4 times 2?
8.
8 times 2?
16.
Right? You see how it's doubling every time? Common ratio, okay? What's different from yesterday?
X is moved.
Okay, x is there, and what used to be there? N minus 1. Okay, so x and n minus 1. It's a little bit different today, but it's the same. It'll produce the same graph. Okay, so exponential growth. So we have exponential growth and decay. Remember how I talked about you getting sick, and let's say you get like infected with like a bacteria or virus, and it doubles every 5 minutes. Remember my conversation about that earlier this week? Okay, same idea, exponential growth. Okay, so it'll look. There's two kinds of graphs for exponential graphs. There's exponential growth that kind of looks like from left to right. Let's say this is your x. Well, let me do this. X and y axis. Exponential growth looks like this. Okay, and then there is x and y axis. Let's say we had exponential decay. It looks like this. Okay. Okay, so this is exponential growth, exponential decay. Okay, so turn to your neighbors and tell them what exponential growth and decay look like, and give them an example of exponential growth and exponential decay. Okay, go. So we're going to do the same thing as yesterday. So here's an example. This is just an example of a problem you might have done for in a test or in homework, okay? But it's the concepts we've been learning, okay? So here's a story. The problem's been worked out for you, but I want you to see what the pattern is, and it'll connect, okay? Ready? So the number of people attending an event doubles each year. What does it mean when it doubles each year? What does double mean? What ratio is double?
Greater.
Times 2, right? You multiply by 2 every time? Okay, the table represents the total attendance at each annual event as a function of the number of the event number n. Complete the table by multiplying each successive attendance by 2. Okay, so on this example, you'll notice that it's the same thing as what we've been talking about. You see how we have 1, 2, 3, 4, 5. This was our first number, second number, third number. What's our first number in the set? How many people are in attendance? 20. And then it doubles. How many are in the second year?
40.
Then it doubles again. How many in the third year?
80.
How many in the fourth year?
120.
And how many in the the fifth year? 320, right? You all see that? Okay, cool. So look in here. Notice how the points are plotted. They took each of the points 120 and they made an ordered pair. They went to 120, they put a point. 240, 380, 4, 160, 5, 320. Y'all see that? Okay. You see how it kind of curves up really quickly? It's exponentially growing. Y'all see that? Okay, that's called an exponential growth graph. Okay? So I'm going to move on here. Sorry about that. Here we go. Okay, so numbers 1 and 2. Okay, what the goal for today is I'm going to teach you how to make the equation for an exponential equation. Just like linear, I taught you how to do y equals mx plus b. Today we're going to do an exponential growth equation, okay, or exponential decay. So the data is all given to you. So just like yesterday, you're thinking, oh, these are all my numbers, 1 through 5, and then this is what's happening. We got the first number is 20, the second number is 40, the third number is 80, the fourth number is 160, the fifth number is 320. Y'all see that? Okay. So the first thing I want to do is figure out what's the ratio that's happening. So from 20 to 40, I'm multiplying by 2. From 40 to 80, I multiply by 2. So what's the common ratio on number 1, everyone? 2, right? So I'm going to put 2 down. So, and I know I'm going to use this equation. Y equals to a sub 1 times b to the x power, okay? Alright, so our ratio, I said, is 2. So I'm going to keep that on the side. Okay? Now, the a sub 1 is not the first term anymore. I want you to think a little bit differently now. A sub 1 is actually the term before it, because I want to know what happens when x is 0. What's anything to the 0 power, everyone?
0.
Nope. 1. Turn to your neighbors, tell them anything to the 0 power is 1. Okay? Okay, good. So what's anything to the 0 power? 1. Okay, so I want to figure out what a sub 1 is. So I want to know what x is 0. So I have to think backwards here. So notice how when I think forwards on number 1, 20 times 2 is 40. Y'all see that? And then 40 times 2 is 80, right? And then 80 times 2 is 160 and so forth. But what if I were to think backwards? I want to know what happens when x is 0. So you see right here, when x is 1, we get 20, right? But what happens when x is 0? Okay? Let's think backwards here. 40 divided by what is 20? 2, right? So 20 divided by 2 is what? 10, right? So when x is 0, a will be 10, okay? Which is a little bit different than what you're thinking about. So we're going to put a is equal to 10 here, okay? And the reason why is, think about it this way. We want to figure out when x is 0. Look on my graph here on the bottom right. Okay, when x is 0, okay? Look at the point here. When x is 1, what's the value? 20. When x is 2, what's the value?
40.
Let's say I go backwards. When x is 0, what should it be? What should the graph look like it's going to? 10, right? Do y'all see that? Because half of 40 is 20. Half of 20 is 10. Y'all see that? Okay, good. So we're going to go back to our problem here. Oops, sorry. So now I'm going to just plug in my numbers. I know a is 10. So I'm just going to put y is equal to a, which is going to be 10 plus our ratio of 2 to the x power. Okay? So 10 times 2 to the x power. And that's your final answer on number 1. Okay? And what this does is it gives us any of the numbers we need. So let's put the 5th number. Okay? Let's pretend I didn't know what the 5th number was on my table. Okay? Here we go. What's 2 to the 5th, everyone? What's 2 times 2 times 2 times 2 times 2? 32. Good. What's 32 times 10? 320. Isn't that the number we have here?
Yep.
Good. And we can use it to predict anyone. What if it was to the 6th? What's 2 to the 6th then?
64.
Good. 64 times 10 is?
640.
Good, then we know it would be 640 and we'd have a plot point up there. Does that make sense? Okay, cool. So that's number 1. I'll do it again on number 2 a little bit more quickly. Number 2 looks a little bit scarier. They give us what happens when x is 0. But I'm going to look at number 2 and I'm looking at it. I see it goes from 1 to 5 here and then it gives us these numbers. 3, 1, 1/3, 1/9, 1/27. So it's a little bit scary. I still have to ask myself, what am I multiplying the first number to get to the next number? So, everyone, what do I multiply 9 with to get 3? And what would you multiply 3 with to get 1? And what would you multiply 1 with to get 1/3? Turn your neighbors and discuss. What would the ratio be on number 2? What do you multiply it with? What do you multiply 9 with to get 3?
Is it 0.3? Wait.
Okay? What do y'all think? Let's take some guesses. It's alright if you're wrong. Yeah, Braden. 1/3. Okay, why is it 1/3?
Because to get 3 from 9, you have to get 1/3 of that.
Yeah, does that make sense? So I heard some, raise your hand if you said like 0.3 or 0.33. Good, that's good too, right? So that's the same thing. So what's the common ratio on this one, everyone? 1/3. We're going to use a fraction, okay? So our common ratio is going to be 1/3. And then we need to know what happens when x is 0. When x is 0, what happens? What does it say? Y is 9. So we're going to say A1 is 9. And we're going to be, we're just going to use that value, okay? We plug in the numbers, and then we get this answer at the end. Y is equal to 9 times 1/3 to the x power. Okay? Oh, that's not the end. So that's how you do numbers 1 and 2. Okay? Is this hard? No, we're just plugging in. And I want you to know, like, if you were to put this in a Desmos or graph it, you'll get all these points on that graph, okay? So what I'd like you to do now, let's see, it's Wednesday. Let's have some students talking, so I'm going to pause. Numbers 3 and 4, here we go. Sorry, that's not the end. 3 and 4, okay? So let's look at number 3. Number 3, it gives us some numbers here. We'll do this one together. It gives us 0, 1, and 2 here, but it also gives us these other ones here, so that's okay. Okay. I want you to tell me what's the ratio. What are you multiplying 1/2 with to get 2, 2 to get 8? Okay, talk to your group. What's the ratio on number 3 here? What's the common ratio, everyone? 4, right? Because if you think about it this way, let's say you had a $1/2. Let's say you had a $1/2. How many times do you have to multiply a $1/2 to get $2? 4. Does that make sense? What do you multiply 2 with to get 8? Y'all see that?
Yes.
Are these fractions hard?
No.
No, you got this. Okay, so what's our common ratio, everyone? 4, good, okay. And then turn your neighbors, tell them what is y equal to when x is 0?
1/2.
Good, 1/2. Y'all see that? Okay, can you all write down the equation for it? You're all doing it right now. You're finishing up this example. Okay? I'll give you about 20 seconds. Y is equal to 1/2, parentheses 4 to the x power. Did y'all get that?
Yeah, I got it right.
Okay, cool. Let's do number 4 now. Number 4 is a little bit more difficult, right? So let's start with the y. Turn your neighbors. You're going to work with them. Think about what do you multiply 6 with to get 4? Okay, or another way to think about it is if you start with $6, what fraction of your money do you have left if you have $4 left? Okay, talk to your neighbors, work, and then you're going to write the equation out. Okay, go. So think about it this way. If you started with $6 and you ended with 4, if you're starting with 6, how much of the total money do you have left? You still have 4 out of $6, right? So what's 4 out of 6 as a fraction? 2/3, right? Or you could have even done it with 9, right? If you start with $9 and you end off with 6, what fraction do you still have? 6/9, right? Okay, finish up my problem for me. What is the equation? Working with your group. So again, your ratio is going to be okay, what's your final answer, everyone? Y equals what?
6 parentheses 2/3 power of x.
Good. That's correct.
6 parentheses 2/3 parentheses to the power of x.
Yep, you can do that too. 6 parentheses times 2/3 parentheses to the power x. That's right. Okay? And I put parentheses around the fraction because I want to make sure that the exponent applies to both the numerator and denominator. Okay? Give me a thumbs up or thumbs down on how you feel about this. Any questions? Raise your hand if you have questions now. Okay, great. So that concludes the lesson.